radio station that's playing in our office only has 20 songs because it feels like it. So I got moved to a different desk, and that's very close to HR and to office management. And they have a radio, and it's loud. It's Magic Radio, and they play ABBA and Queen and a bunch of other things I'm too young to remember. But I think there are roughly 20 of them. I'm not sure, but we do have bets going on in the office. So we're thinking, how can I find out? Well, let's look at the HTML source of the website. And it turns out there's this little script thing in there that has this ID next data, and then it says, oh, it's application JSON. Let's have a look. Well, actually, it contains this wonderful data structure that is about the last 20 songs, I think, or 25 songs they've played. And, well, there's a track ID, there's a track name, an artist, and the time when they played it. That sounds about right, yeah? So let's make a database. It's easy, it doesn't have to be normalized. It's just like a single SqlLite table with those 4 fields. And we'll just make the playing time the primary key because, well, there's one radio station, they're not going to play 2 songs at the same time. Then we'll make a tiny cron job, use Mojo user agent, grab the page, grab the grab the JSON out, parse it, stick it in the database. Cool. Run this every hour. Now we've got a history. And if my computer keeps running, it's a very nice history. Like I've been collecting data in for the last 3.5 weeks, I think, almost 4 weeks. So yeah, then we use DBIx class schema loader to make some classes. So we're only looking at the schema ones right now. There's the result, which is the thing generated by the schema loader. And then I've made a result set for it. And we're going to look at that in a bit more detail. So that's what we're going to put our business logic. This is just an example. It doesn't really matter what's going on there. But there's a function that you can call to, for example, find the top artists. And that will return a new result set with a filter. And of course, you can chain result sets, which is quite useful. We'll get to that later. So, separation of concerns, that's not only a thing in web applications. If you make a command line application, that's kind of useful as well, because we have our business logic, it's in the schema, and in the classes associated with the schema. So yeah, we can have a command line application. It could look like this, where it basically has the program you call, and then you have different commands, and the commands can have flags. And I think Mohammed blogged about this yesterday, or 2 days ago, but there you are. This Moo implementation, we're doing this. So I decided to go with a Moose implementation. And yeah, this is, so yesterday the top artist was Madonna with 7 plays. I think it was all different songs. So fun fact is there are songs that they really like. And they play the same song sometimes 2 or 3 times a day. And then there are artists they really like ABBA, where they can have 7 or 8 plays a day. But they never repeat a song, and sometimes they even manage to not repeat the song within 2 days. So I've opted for MooseX app command, which is a mashup of MooseX getopt and app command. And it's really cool, because it's super easy and you don't actually have to do much. Can't remember who wrote it. I think Karen Etheridge is releasing it right now, but that doesn't really say anything. Because she owns half of Super, right? So yeah, this is the first step. We create a script. And all that does is use the module we create in the next step and call run on it. That's fairly simple. After that, we make this application package, which is really a Moose class that extends MooseX app command and nothing else. So again, it's fairly simple. And then we can make different command packages. So now those map to what we've just seen on the command line. In this case, we want to find out who the top artist was. So there's this package, it has to be in this command, the CMD command namespace, and then the name of the package is converted into the command you give to the program. It extends the MooseX app command, and I've stuck 2 roles in there, which we will discuss in a few slides. The main thing is this execute sub, which takes a bunch of arguments that we don't really care about, all we need is self. And then on self, we have a result set. I've put that there through this role here. We'll discuss this in a moment. Yeah, we call this result set, and then we go, give me the top artists. We saw a little bit of code on the previous slide, and then give me all the results, loop over them, we're done. And then it says, well, 7th place of Madonna, or over the whole time, maybe, I don't know, 500 of ABBA or something. Yeah, so how do we get the database in? We make a role. Because it's Moose, that's really convenient, and if we make a role, we can reuse that in all the commands. Well, we could make a base class as well and then inherit, but there are some things that you don't want to inherit into all your commands, like flags, like this yesterday that we also saw in the previous slide. There could be some metrics we want to look at that can have a time-based component, like give me the top songs for yesterday, give me the top artists for yesterday or for last week, but you can't really do that for everything. So there are a couple of commands that I've written that don't do that. So role makes sense, but for the database itself, we'll have the role. So we've got the schema, which is a Moose property. It has this getOp trait. Well, actually has a no getOp trait, which tells the MooseX getOp thing to not have a command, like have a flag for this. Everything else will automatically be turned into -- something, and then you can switch it on or off or give it values. It's quite convenient. Well, it connects the schema, and that's it. And then we have the result set, and that's the thing we really want to make available. So that's a read-write property, because we're going to use the fact that we can set it to something else to keep making the query bigger and bigger, or making the conditions on the query bigger and bigger, so that we can have more filters based on flags. Well, we just built the result set. Fairly straightforward. So then we have another role for flags. And now this is really cool. So this is time-based in this case. It requires the result set. That's one of the Moose role keywords. So it says the class I'm being composed into needs to have a method called result set, which is the accessor from the other role. And because of that, we need to have 2 with statements, whereas usually you don't really have multiple with in your Moose class, because that's inefficient. If you want to require something from another role, you need to load that role first. Otherwise it doesn't work. Okay, so we've got yesterday, that is a getOf, it's a bool, and it has this little documentation, which means if you go command help, it will give nice documentation of which kind of commands you can run. And I've got these flags, they're not really important, there are a couple of them, we're only looking at one of them. And then we have a hook. So this is a little bit like the phasers, really, isn't it? But not really. But a little bit. A method modifier that runs before the execute, and we don't care about the command about the return value. So it's just return. We say for all of the flags that we've got, in our case, that just care about yesterday, check whether that flag is true, and if it is, call this method on the result set. So we've implemented another method in our result set class that will augment the filter, and that returns a new result set, and then we override our result set with the new result set. So then instead of having the entire database, which is what it started with, as we saw in the previous one, where it's just the entire database table, it is now the database table, for example, where it says the date has to be larger than yesterday at 0 hours. So that's that's for today actually, not yesterday. So yesterday would be -2 days to start until like the end of -2 days. Right. So now let's run it. I've turned DBIx on, which gives you this really nice output. Actually, there's also DBIx profile equals console, but I've not written that down. So it creates this this nice SQL. Doesn't really matter what it does. If I put the flag in, there's suddenly more SQL, because it's basically combined these 2 result sets because they're chained, and makes nice SQL, and we find out it's 141 plays of ABBA, that's the top artist, over the entire 3 weeks and something. But if we look at only yesterday, the top artist is Madonna. And so these 2 are competing. I think ABBA is winning. But, well, so do they actually only have the same 20 songs? Really? Let's check. So I made a unique songs. Ooh, 677 different ones.
They all sound the same.
What?
They all sound the same.
Most of them. Like Queen and ABBA sound different. I don't mind Queen so much. I think the most played song might be Dancing Queen, so that's maybe related, I don't know. But as I said, they also have artists where they play the same song every day. That artist only has that one song. And it's not the song I know of that artist.
Now you know it.
Yeah. So okay, let's try and make this more viable. Let's say we're doing it in the working hours, 9 to 5, right? And we're not running code after that. So we're not listening to the radio. Now it's 506. That's still way too many. So so we have the saying in German: you cannot trust a statistic that you haven't falsified yourself.